Hey, and welcome back to the channel. Today we will solve two sum 2 interview question. This question has been mostly asked by Amazon as well as some other companies like so. Quick hint, we will use 2 pointers for this, so without further ado, let's dive in. So, first example here, we have a sorted array which we need to find two numbers that will add up to 9. So index 0 and 1 will give us that result. But one important note here, this question requires us to add 1 to our founded indices. Some weird demand, so it will become 1 and 2. Second example, we have 6 as a target, 2 and 4 will add up to that. So indices will be 1 and 3 added by 1. And last example, we are looking for -1. So -1 with 0 will add up to our target. We will return respective indices for those two numbers added by 1. Let's see how we are going to solve this problem. If we are dealing with array data structure and if interviewer or problem itself states that array is sorted, honestly, that's a big hint for us. It literally says that either you can use binary search or you can use 2 pointers based on what problem asks from us. In our case, we will need to use 2 pointers. It will bring us O of n time complexity. We will explore more problems with binary search in future, so make sure to subscribe to the channel in order to not miss those videos as well. But what is 2-pointer search method? Let me explain it quickly. Here we have our first example with extra 1 in the beginning of it just to show you the full search flow. Basically, if we are looking for a specific number and we have a sorted array, the idea is that we can put 2 pointers in either side of array and sum those numbers to see if they add up to the target number that we are looking for. So 1 plus 15 will give us 16, but 16 is still higher than what we are looking for. Now the main question becomes, our sum is bigger than our target value in here. We definitely need to move one of those pointers around to try more, but how we are going to know which pointer to move, left one or right one? This is also simple. If we have bigger number than our target, like in this case here, considering we have a sorted array, in order to get closer to our target number, we can decrement or higher pointer by 1 and calculate the sum again. Because clearly we are in upper range than our target, and if we increment it, we will get even higher values than what we are currently have. So as a result, this time we will have 12. It's still higher. Again, we will decrement right pointer one more time. This time we got 7, and if we sum them up, look, we will get 8 in this case, which is lower than the target. So the logic will become reversed this time, since we get lower value than our target. Again, considering we have a sorted array, we might increment our lower pointer because we are in the lower range of our target. And in a consequence of that, if we sum those numbers together, we will get our target value. In fact, by incrementing lower pointer and decrementing higher pointer by 1 each time in our search flow, we actually getting closer and closer to our target. Let's see how we are going to implement this in code. So here we are in leetcode. We will start by creating our 2 pointers. So we will do let left equal to 0, let right equal to nums.length -1. Then we will do our while loop. While, as long as left is less than right, we need to do some stuff inside. We need 3 checks. First one is if numbers in both pointers location will add up to our target. If that is the case, then we found our answer. So we will do if nums at left index plus nums at right index is equal to or target. If that is the case, then we need to return left and right pointer. But remember that question was requiring us to return indices added by 1. So we will do +1 here and +1 in there as well. Second check is for our left pointer. Else if nums at left pointer plus nums at right pointer is less than our target. If that is the case, that means we are currently at lower range than our target. So we need to increment left pointer by 1 in order to try more. And finally, check for the right pointer as well, like else if nums at left pointer plus nums at right pointer is larger than our target. That means we are in higher range than our target, and we need to decrement our right pointer like so. And now if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's go back to slides for time and space complexity analysis. For time complexity, we will have O of n because we just added a while loop over our nums array. For space complexity, it's going to be O of 1 constant space complexity because we didn't add anything that uses space except our 2 pointers, which were just 2 variables. This question was sitting between 2-sum and 3-sum problem, and I have videos for both of them. I'll put the link in the description of this video in order for you to check it out. With that, I can say that was it for this video, and please subscribe to the channel in order to not miss out new videos. Also, I will put the link for arrays playlist in video's description as well, where we go through solving some array problems. So thank you for watching, and please like, comment and subscribe to the channel. And finally, hope you enjoyed this video and stay tuned for the next one.